On this Silverado diesel, P0183 is a fuel temperature sensor circuit high voltage code. In plain language, the module may be seeing a fuel temperature signal that looks colder than expected for the circuit. The truck may have a check engine light, and depending on the fault, it can have fuel system or drivability symptoms. But this diagnosis is mainly about proving the sensor signal, low reference, ground, wiring, and the fuel pump driver control module path before calling a part bad. Before getting into the pinpoint tests, start with the basic system checks. If other codes are present, check what they mean first. Then follow a structured diagnostic approach so you are not chasing a circuit fault with a broader vehicle problem still active. Use the fuel temperature scan value to decide which direction the circuit is pointing. The normal parameter range is -39 to 109 degrees Celsius, -38 to 228 degrees Fahrenheit. In the typical scan data, a signal short to ground is shown as signal 110 degrees Celsius, 230 degrees Fahrenheit. A signal open is shown as signal -40 degrees Celsius, -40 degrees Fahrenheit. A signal short to voltage is also shown as signal -40 degrees Celsius, -40 degrees Fahrenheit. And a low reference open is shown as low reference -40 degrees Celsius, -40 degrees Fahrenheit. That is why this P0183 path pays close attention to a cold-looking scan value and then proves the wiring before blaming a component. For P0183, treat the running conditions as monitor gates. The fuel pump driver control module voltage signal has to be greater than 8 volts. Ignition is on or the engine is running. Ignition voltage has to be greater than 11 volts, and the monitor runs continuously after those conditions are met. The setting condition for P0183 is the fuel temperature sensor reading colder than -39 degrees Celsius, -38 degrees Fahrenheit for greater than 2 seconds. With ignition on and the vehicle in service mode, look at the fuel temperature sensor parameter. It should be between -39 and 109 degrees Celsius, -38 and 228 degrees Fahrenheit, and it should change. If it is in that range and changes, reproduce the operating conditions, or reproduce the captured conditions, and verify P0183 does not reset. If the code does not reset, that path checks good. If the parameter is out of range, does not change, or the code resets during the check, move into circuit testing. For circuit testing, turn the ignition and all vehicle systems off. Then disconnect the E11A fuel heater water and fuel sensor connector. Remember, it may take up to 2 minutes for all vehicle systems to power down before a ground or low reference continuity test is accurate. Test the low reference circuit at terminal 7 to ground. You want less than 10 ohms. If terminal 7 to ground is 10 ohms or greater, disconnect the K111 fuel pump driver control module connector and isolate the low reference circuit. Test from low reference terminal 7 at the component harness to terminal 19 at the control module harness. The circuit should be less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance in that circuit. If that low reference circuit is less than 2 ohms, move to the control module ground side. Test ground circuit terminal 14 at the control module harness to ground. It should be less than 10 ohms. If it is 10 ohms or greater, disconnect ground G415 and test ground circuit terminal 14 to terminal G415. That should be less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance in the circuit. If that section is less than 2 ohms, repair the open or high resistance in the ground connection. If terminal 14 to ground was already less than 10 ohms on this branch, the procedure calls for replacing the K111 fuel pump driver control module. If the low reference circuit terminal 7 to ground is less than 10 ohms, turn ignition on with the vehicle in service mode. Now verify the scan tool fuel temperature sensor reads colder than -39 degrees Celsius, -38 degrees Fahrenheit. If it reads warmer than -40 degrees Celsius, -40 degrees Fahrenheit, turn ignition off, disconnect the K111 fuel pump driver control module, and test signal circuit terminal 6 at the component harness to ground for infinite resistance. If you have less than infinite resistance, repair the short to ground on the signal circuit. If resistance is infinite, the procedure calls for replacing the K111 fuel pump driver control module. If the scan tool does read colder than -39 degrees Celsius, -38 degrees Fahrenheit, connect a 3A fused jumper wire between signal circuit terminal 6 and low reference circuit terminal 7. With that jumper in place, the fuel temperature sensor parameter should go warmer than 109 degrees Celsius, 228 degrees Fahrenheit. This is the sensor simulation part of the test. You are proving whether the module can see the circuit move when the signal and low reference are tied together through a protected jumper. If the scan value stays 109 degrees Celsius, 228 Fahrenheit or colder with the jumper connected, turn ignition off, remove the jumper, disconnect the K111 fuel pump driver control module, then turn ignition on with the vehicle in service mode. Test signal circuit terminal 6 at the component harness to ground. You want less than 1V. If it is 1V or greater, repair the short to voltage on the signal circuit. If signal circuit terminal 6 to ground is less than 1 volt, turn ignition off and test continuity from signal circuit terminal 6 at the component harness to terminal 4 at the control module harness. The circuit should be less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance in the signal circuit. If it is less than 2 ohms, the procedure calls for replacing the K111 fuel pump driver control module. If the fused jumper makes the fuel temperature sensor parameter read warmer than 109 degrees Celsius, 228 degrees Fahrenheit, the circuit response is correct on that branch. At that point, the procedure calls for replacing the E11A fuel heater water in fuel sensor. After the repair is complete, keep verification separate from the circuit testing. Verify the repair and confirm P0183 stays gone under the operating conditions that run the monitor. The key with P0183 is to prove the low reference, ground, and signal circuit response before condemning the sensor or the module. Work the branches in order, protect the jumper test, and let the scan data confirm the direction. For more diagnostic training, visit stepdiagnostics.com.